Nathaniel, and I'll be doing question one for the exam. So, part A asks unpolarized sunlight in air shines on a block of transparent solid with index of refraction 1.73. For what angle of incidence is the reflected light completely polarized? So, for this question, we're going to be using Brewster's law, and it simply describes that we have to use the formula tan theta p equals n b over n a. So right now the information we have is that unpolarized sunlight in air shines on a block of transparent solid with an index reflection of 1.73. So air, the light is coming from, I guess, inside the air. And so that has a refraction index of 1.0 pretty much. And so we're gonna pretty much write down all our index of refractions that we have on a little graph right here. So right here is the dividing line between the solid and the air. And write that down, air right here, and A equals 1.0. And then the solid is a refraction of NB equals 1.73. So we're trying to find theta p, which is the angle. So let's just draw the little diagram. Theta p is here. And we have NA and NB already, all right? So all we have to do is plug it in. So that'll be 1.0 under 1.73. And so that'll equal tan theta p. And now all we have to do is to pretty much inverse it. So we could get the angle from this. 1.73 over 1 is obviously 1.73. So let's just do this real quick. So arc tan, real quick, 1.73 equals an angle of 60 degrees. So the angle of incidence is 60 degrees for the reflected light to be completely polarized. All right. So for part B, let's just circle this real quick for A. For part B asks for this angle of incidence is the light refracted in the solid completely polarized, partially polarized, or unpolarized. So it's just unpolarized light going sunlight into going into the solid from the airs, and so from this angle the light that's going in is just only partially polarized. So let's just write that down. Partially polarized B, because it's not the reflected light, it's the refracted light going inside. And for part C, now it's asking you shine a beam of unpolarized light in air on a block of glass. You find that if the angle of incidence is 57 degrees, the reflected light is completely polarized. Find the index of refraction of the glass. So the light is coming from air into a block of glass. So let's just draw that real quick. So air is coming from here. We know that air is and will be, so air is over here. NA, since it's the beginning, it'll be NA equals 1.0. That's where the light is coming from, NA. So 1.0, and then the glass. Wait, actually, no, it's the, yeah, it is glass. So glass, you find that if the angle of incidence is 57 degrees, so this angle is 57 degrees. Hold up, 57 degrees equals theta p. Then what we have to do is pretty much just use tan, really. Um, so because what was it? It'll be like this: tan theta equals um NB over 1.0 because NA is 1.0. We would use pretty much this would be NA right here at the bottom, which will equal 1 under NB because we don't know what NB is. That's the glass that's being reflected on. And so since 1 dividing anything will just equal whatever that thing is, so NB divided by 1 is just NB. All we have to do is find the angle that would equal NB. So, well, we don't have to find the angle. We have the angle already. I mean, to find NB is to use the angle that we have, which is 57 degrees right here. So 57 degrees tan equal tan 57 degrees equals NV. And since we could just easily put that on a calculator, that'll be 1.54. So the reflected light for the wait, so the refraction index for the glass for the light to be completely polarized at 57 degrees is 1.54. So right there, that'll be for C. And now it's asking find the angle of refraction. Right. So to find the angle of refraction, all we have to do is start pretty much say it like this. So the light's gonna be like this. So the light goes in to the glass at a what was it called? 90-degree angle of the reflected light, I mean. So it'll be like this. Let me try to write it properly. So right here, this is 90 degrees. And for this to be pretty much, what was it called? Let's just put this line down here. So right here, if we add up all these angles together, this line straight down from, I guess, where they meet, so the perpendicular line to the right here, it'll equal 180 degrees of the theta p, the angle of reflection of the light, and then the 90 degrees plus whatever the refracted angle is. So to get that refracted angle, all we have to really do is subtract all of this from 180. So 57 minus 180. All right. So that's simply, let's put that right here, 3, let's put that as 7, 2, 1. All right. And now we also do the 90-degree angle here, right here. So that'll be 90 minus 123, which will just equal 3. And that'll be 3 and pretty much 0. So it's an angle of 33 degrees, the refracted angle from this line right here, this perpendicular line from the materials. So, yep, right here, this is theta B. You just write all this down. This is for D. All right. So for part E now, it's saying you shine a beam of polarized light in air on a piece of dense flint glass, n equals 1.66. If the polarization direction is perpendicular to the plane of incidence, is there an angle of incidence for which no light is reflected from the glass? If so, what is the angle? So we're talking about polarized light and it's perpendicular to the plane of incidence. So there's pretty much no angle for which the no light reflects from Brewster's what was it called? Brewster's law, pretty much Brewster's law of angle law. So it's pretty much just not possible to get an angle where no light reflects if it's perpendicular. It'll just always bounce off. And so for part F, let me just actually write that down too. So for E, no angle for no light to be reflected when the polarization direction is perpendicular to the plane of incidence. If the light is polarized. Brewster's law. All right, so for F, it's asking if the polarization direction is in the plane of incidence, is there an angle of incidence for which no light is reflected from the glass? So since the polarized light is parallel pretty much, um, yep, it's in the plane of the incidence. The polarization direction is in the plane of incidence. Is there an angle of incidence at which no light is reflected from the glass? So this pretty much is the same formula as before. Since this light is what was it called? Polarized. Now there's no reflection. So pretty much once again, we're using tan theta equals NB over NA. Well, tan theta, all right. So what was it called again? So we have, let's just draw this all out right now. So there's an angle where it has to be reflected. It'll be like this. There's 1.0, where there's no reflection. So was this angle where this is not possible? So let's see real quick. We have 1.0 from the air. It is coming from air. And then 1.66. So Na equals 1.0 and 1.66 equals NB. So just write everything down again. So tan theta equals NB over NA, whoa, which is 1.66 over 1 plug that in for arctan to get the angle. Arctan equals, well, arctan 1.66 equals 58.9 degrees. So that's how we get part F. Did we, oops, did I mess it up? So 58.9 degrees for F. And now for the last part, which is part G, let's write this down. Well, not write it down like that. But what was it called? It'll be asking a glass container holds water, 1.33. If unpolarized light propagating in the glass strikes the glass-water interface, the light reflected back into the glass will be completely polarized if the angle of refraction is 50.5 degrees. Find the polarizing angle in this situation. So right now we're trying to find the angle in which the light will be pretty much just polarized. Okay. So we have a bunch of information pretty much already to answer this pretty easily. So let's just write down our diagram. So the light reflected back into the glass will be completely polarized if the angle of refraction is 90, wait, no, it's 50.5. So refraction right here. So this angle, oops, that is not a straight line. So let's just do these little lines perpendicular. It'll be right here. So this will be the angle of refraction. So this is going to be P equals 50.5 degrees. All right. And so for this, what was it called? It'll pretty much be like that other question over there that we did over here where we found the refraction. But instead we were just finding the reflection. Um, so 55.5 degrees, and then 90 degrees will be right here because this angle right here will always be 90 degrees from the reflected. So right here, this is 55, this is 90 degrees. So 90 degrees here. And then this last angle right here, which is the reflection angle, will be, well, the polarizing angle. Um, it'll be just whatever adds up all these together to 180 degrees. So all we have to do is just pretty much, we could just add these together. So it'll be 90 plus 50.5. That'll equal 5.0. And that'll be 4, 1. Now all we have to do is subtract that from 180 to get the rest. So let's get this over here. So 140.5 minus 180. Well, 180 minus 140.5. So just do the quick math. So 5, 3, 9. That'll be 3. That'll be, yep, 39.5 degrees. So so when it comes to the polarizing angle, it's just 39.5 degrees. I mean, we did get information for like the glass container holding water, like it's just 1.33, but it's not necessary since all we have to really do is just subtract that from 180 to get that angle, since it's just nice coincidence that all this added up is equal to 180. So right here, goes 39.5. So let's circle that. That'll be for part G. All right. That should be all the parts. Thank you for watching, and